Hey 6th grade, here's our learning goal for our next video, and you need to make sure you get it in your notes. So, our learning goal is, I will recognize how to use common factors and common multiples to solve problems. So make sure you hit pause and you get this in your notes. So first of all, we need to make sure that we know the difference between common factors and common multiples because they kind of all sound the same. So common factors, and make sure you get all of this in your notes, common factors help you think about how to divide or share things equally. So common factors help you think about how to divide or share things equally. And when I think of factors, I kind of remember that they're the little pieces that get put together to make the whole. All right? And then common multiples help you think about how things with different cycles can occur at the same time. And with common multiples, remember to think a whole lot about skip counting because that's going to be very important when it comes to finding the common multiples of numbers. So make sure you hit pause, make sure you get it all in your notes. All right, so we're going to try some problem solving we have to figure out if we're going to use greatest common factor or least common multiple. So let's see here. We have two bikers and they're riding on the same circular path. So there's riding in circles. The first rider completes a lap in 12 minutes. All right. The second rider completes a lap in 18 minutes. Both riders start at the starting line at the same time and they go in the same direction. So if the riders maintain their speed, how many minutes will it be before they meet at the starting line again? So do we need to find the least common multiple or the greatest common factor? I'm going to say multiples because they're going to ride around that track multiple times. So multiples, and I realize that I'm also going to set this up just a little bit differently. So for multiples, I want to be able to make lists here. So we have 12, let's see here. So we start with 12, 24, 36, 48, 60. And then let's find my multiples of 18. 18, 36, 54. And I already see our least common multiple here in my list, so I'm just going to stop. And so I'm going to circle the 36s. And so the riders will meet again in 36 minutes because 36 is the LCM, or the least common multiple. All right, this time we're going to pretend that we are making, veggie trays, all right? So we have 72 carrot sticks, we have 56 pieces of cauliflower, and we have 64 pieces of broccoli. And I do hope I've lined this up so I have enough space. And we need to try to find the largest number of trays we can make, with each tray having the same number of each vegetable on there. So you want to divide the carrot sticks evenly and the cauliflower and the broccoli evenly between all of the trays. So that means we're going to try to find the GCF, the greatest common factor. So let's make some factor trees here. We have 36 times 2. That one can't go any farther. Then we have 9 times 4. We still have to keep factoring those down even farther. We have 3 times 3 for 9. That's the end of that. And then for 4, we have 2 times 2. I'm just running out of space, so I'm going all over the place. All right. So now for 56, we have 7 times 8. Now 7 is a prime number, so we'll circle that. Can't go any farther with that one. 8 is 2 times 4, so we'll circle our 2. And then the 4 can be factored just a bit farther down to 2 times 2. So we'll circle those prime numbers as well. And then for 64, we have 8 times 8, which then goes down to 2 times 4 for both of those. 2 times 4, so we'll circle our 2's because we know we can't go any farther. Those are prime. And then we have 2 times 2 and another 2 times 2. Right? And we're going to circle all of those things. That is a lot of 2's. So, excuse me. So now we need to make lists of our factors. So for 72, we had 2 times 2 times 2 times 3 times 3. For 56, we had 2 times 2 times 2 times 7. And then for 64, we had 2 times 2 times 2 times 2 times 2 times 2. Did I get them all? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. And now for the greatest common or least common. Oh my gosh, I'm losing my mind. So the greatest common factor of 72, 56, and 64, we have to circle the common factors, and then we have to multiply them. 2 times 2 times 2 equals 8. So that means that we can make 8 trays of veggies and have all 8 trays have the same number of each type of vegetable. So we found the greatest common factor in that problem. All right, for our next story problem, we have one about this Dr. Abramson, and she's a scientist. And she and her assistants are working on 3 different experiments using water. For the first experiment, the water must be checked every 12 seconds. In the second experiment, the water must be checked every 30 seconds. And in the third experiment, it must be checked every 36 seconds. So, if all the experiments start at the same time, when is the first time all 3 experiments will need to be checked at the same time? So, we're going to have to find the least common multiple of 12, 30, and 36. So we'll start with skip counting by 12. 12, 24, 36, 48, 60, 72, 84, 96, 108, 120. I have a feeling I might need to write more than that. Skip counting by 30s, we have 30, 60, 90, 120, 150, and 180. Oh boy, I'd better add some more up here. So 12s, then we'd have 132, 144, 156, no, that's not right. Yes, it is. 156, 168, 180. Ooh, okay, maybe we'll stop there because we've got 2 numbers that are the same. So down here we'd have 36, 72, 108, 144, and wouldn't that be, yeah, that'd be 180. All right, and our next multiple is 180. So the least common multiple of 12, 30, and 36 is 180. That means the next time all 3 experiments will be checked at the same time will be in 180 seconds because that is the least common multiple. Oh my goodness. Let's try labeling that as seconds. There we go. So make sure you get all of these notes written in your math binder. All right, we're going to do one more problem together that you better be getting in your notes. And at the end of this particular video, you will not have any other problems to solve on your own. So we are going to pretend that we are working at summer camp and we like to have healthy snacks during the day. So we're going to make snack bags that have little boxes of raisins and granola bars. So if we have 72 boxes of raisins and 64 granola bars, what is going to be the greatest number of snack bags we can make? Now the word greatest gives us a clue. We're going to be trying to find the greatest common factor, or GCF, of 72 and 64. So let's do our little factor trees. We have 8 times 9. Neither of those is prime, so we need to keep on factoring them. We have 4 times 2, and then 3 times 3. We can circle the 2, because we can't factor that out any farther, and same with the 3's. And then the 4 can go just a little bit more. There we go. So our factors of 72, we have 2 times 2 times 2 times 3 times 3. Then up here for 64, we have 8 times 8. And those are not prime numbers, so we can keep right on factoring those things. We have 4 times 2, and circle that 2. And another 4 times 2, and circle that 2. And factor out the 4 all the way down to the 2's. Can't go any farther with that one. And same with the other 4 up here. We'll put that as another 2 times 2 and circle those. And then we have to make our lists. We have 72, we have 64. So for 72, we have 2 times 2 times 2 times 3 times 3. And then for 64, we have 6 2's. We have 2 times 2 times 2 times 2 times 2 times 2. So we have to circle the factors that are the same, and we're not going to worry about any of the others. So just circle the ones that are the same. And we have 3 sets of 2. So we have 2 times 2 times 2. Let's see, 2 times 2 is 4, 4 times 2 is 8. So that means that the greatest common factor of 72 and 64 is 8. It also means that 8 is the largest number of snack bags that we can make with our raisins and granola bars. So I hope you got all of this down in your notes. Feel free to rewind it, rewatch it, whatever you got to do to make sure that you have all of this in your notes, and I'll see y'all in class.